The domain of the function is the set of all first components of the ordered pairs of the function. Or in other words, the domain is all the values of x that valid for particular function. Then the range of a function is the set of all second components of the ordered pairs of the function. Range is the values of y that valid for any particular function. Here is the mapping diagram that you have learned before. So here is the set of all the domain, which is x, mapping to the set of all the range, which is the values of y. For a constant function, as you know, the meaning of constant function is when the highest power of x in the function is 0 or there is no x in the function. That's the meaning of a constant function. So if you look for this example, fx equals to -5, the value of x can be anything. All real numbers is valid for this function because no specifically restriction apply. So the domain, we write this as capital D, small f here, meaning that particular function. So the domain f is equal to all real numbers, or interval notation you have learned in chapter 1. It will be negative infinity until positive infinity. For range, since the range is the value of y that valid for the function, as you can see, this function, all the value of y is only -5. So the range is only the -5 element. That's how you determine the domain and range for a constant function. Here, there is no restriction applied for the values of x or linear. So the domain will be -infinity until positive infinity, because all the values of x can be substituted into this function and the function is still valid. Same also applied for range. Since all the values of x can be substituted into this function, so the range will be all real numbers also. Understand? Contrary to the example B. As you can see in example B, there is a restriction applied for the function, which is they mention here the values of x in this particular function must be from -2 open and including 6. So the domain, as you have learned before how to write in the interval notation, is like this. Then how to find the range, the values of y that valid for this function? You just apply these two values, sub it into the function back. So f -2 will be -2 over 2, which is -1. f6, it will be 6 over 2, which is 3. So the range is from -1 until 3. For the domain, it will be the same like linear or constant you have learned before, because there is no restriction for this function. It's only square. So all values of x can be substituted into this function, and in the same time the function is still valid. So the domain is from -infinity until +infinity. But for the quadratics, since you have learned before quadratic function, the shape of the graph is either like this or either like this. So it will have a turning point, or we call it minimum or maximum point. Minimum or maximum point. So this minimum or maximum point is the key for the values of y, or the range of that function. The formula for minimum or maximum point, the x coordinate is -b over 2a. So you need to find first the coordinate for minimum or maximum point. For this particular function, since the value of a is negative, so it will have the maximum point. Maximum point here, x equal to, since the b is 0, so -0 over 2 times -1, which is still 0. Understand? Okay, but now you don't want the value of x to find the range. You want the values of y. So from the value of 0 here, you just sub f0, which is the value of y, is equal to -0 square plus 1, which is 1. Okay, then since it is a maximum point, so the maximum value of y in this function is 1. So the function valid only from -infinity until 1 for the range. Understand, everyone? we move to B. Okay, for B, same, because there is no restriction applied here. Then we go to the domain. It will be from negative infinity until positive infinity. Then for the range, you have learned, since A here is negative, so it will have the maximum point, which is x equal to negative 3 over 2 times negative 1, which is negative 3 over 2. Then because you want the range, you need the value of y, so you just substitute the value of negative 3 over 2 into the function back. So f negative 3 over 2 is negative 3 over 2 square minus 3 negative 3 over 2 plus 2. Then you calculate, you will get 17 over 4. So here the maximum value of y for this function is only 17 over 4. Hence the range, it will be negative infinity until (17 over 4). Close. Okay, for example C, contradict to example A and B, as you can see, there is a restriction for x here. So the domain, it will not be from negative infinity to infinity. It will be from negative 1 until 4. Close, because inclusive. Okay, then how do you find the range? Okay, first of all, as you have learned, you need to find the value of maximum or minimum point first. So you look here, meaning it is a maximum point. So the maximum point negative 1 over 2 times negative 1. So it will be negative 1 over 2. Then you don't want the x, you don't want the y. So f negative 1 over 2, you sub back into the particular function like that, and then how do you get it? You will get 25 over 4. So the maximum value for this particular function is only 25 over 4 for the values of y. Then we need to confirm the minimum value, since there is the restriction here. It will not be at negative infinity. So how do you decide? How do you decide? you find the value of each function. So f -1 here. So -1 square minus -1 plus 6, which is equal to 6. And then f6 -6 square minus 6 plus 6, which is equal to -36. So which one is smaller there? -6 or -36? Here is smaller. Hence, this is the minimum value of y for this function, and this is the maximum value of y for this function. So, the range will be -36 until 25/4. Understand? Since all the values of x can be substituted into this function, so the domain is -infinity until +infinity, and the range, it will be also -infinity until +infinity, since there is no restriction applied. Same also for here. If you expand, it will be 3x squared minus x cubed. Since this form, there is no restriction can be applied to the function, so the domain will be all the real numbers, -infinity and infinity, and the range also, it will be -infinity until +infinity. Understand? Third function, for the third function, here, as you have learned before, you cannot have third negative value here, meaning the value inside the set, it cannot be negative, or in other words, here it must always be greater or equal to 0. So there is a restriction for x. As you can see, x minus 4, so fx is only valid for x minus 4 greater or equal to 0. Then you have learned in chapter 2, you rearranging the inequalities, you will get x greater or equals to 4. So from here, the domain of the function is from 4 close to infinity. Understand? And then, if you calculate the value of set itself here, the minimum value of set is only 0. It cannot be negative. Am I correct? So the range will be 0 to infinity. For example B, 3 minus x. Okay. First of all, look carefully. The function itself is 3 minus set x. So, for the domain, fx is valid for x greater or equal to 0 here. So df is 0 to infinity. Then for the range, look carefully. Okay, since the function is 3 minus set x, okay, you have learned set x is always greater or equal to 0, because mathematically or logically you cannot have the value of set negative. Then we slowly obtain from here to here. So we put negative first, negative set x. Since we put the negative, we must change the inequality symbol, the direction. Okay, and then we put 3 here, both sides. So here is the function itself. So fx less than or equals to 3. As the conclusion, the range is negative infinity until 3. Understand? The value of x under the denominator cannot be 0. So, since x plus 2 cannot be 0, x cannot be negative 2. Other than that, no problem. Understand? For the range, you can see here fx, since it starts with 1 here, so fx can be any values except for 0. Do you understand that? Since it is already 1 here, so the range will be any values except that 0. Understand? Okay, for part B, so you have learned since 3 minus 4x for the domain cannot be 0, so 3 cannot be 4x and x cannot be 3 over 4. So the domain is and everything except for x cannot be 3 over 4. Understand? And then for the range, as you can see here, the function itself, so it cannot be only 0. So the range will be from negative infinity, positive infinity. Y cannot be 0. Understand?